Well, I want to start out talking about the power of classification, and there's an article to read in the New York Times. I have a PDF saved of this article. So if you have run out of articles that you can get for free on the New York Times, I will send this to you. It is legitimate for me to send this to you because the University of Wyoming does subscribe to the New York Times. But this is what it looks like when you've run out of articles. But here is the article over here in a different browser. Okay. And it says algorithms could bring an end to the world's deadliest killer. The deadliest killer, they say, is tuberculosis. I think possibly the deadliest killer. The other contender for this would be malaria. Um, and I haven't exactly looked at their numbers, but they say it kills 1.4 million lives a year. I think malaria is slightly higher, but that's not a disease, it's a parasite. In any case, as diseases go, this is definitely the one that kills the most people. And the particular app they're talking about is this QXR, which uses a convolutional neural network to identify 27 different conditions in X-rays and allows a doctor to be able to look at and identify X-rays without a radiologist being used. And certainly this is making a dramatic impact in large portions of the world, where they can actually take an X-ray, have the software do the analysis, and tell them what they're looking at. And it does two things. The first thing is it's really good at eliminating the negatives. As in, you take an X-ray, it says it isn't these things, which means that the only time that they actually have radiologists or doctors looking at the details is over here where it is something. So it's really good at that. And, this is a pure classification thing. This isn't some magic piece of hardware or a robot arm or some big, complicated, hard-to-build thing. It's basically an app on a smartphone that you send it the images, and it takes a look at the images and processes them. So this is a pure digital thing. And once it's identified that there is something, it can give you a likely classification of what it might be in the X-ray image. And that means that a lot of things that they say, is it tuberculosis or is it not? You can say, yeah, this is this, or this person is having this kind of a problem. And this is a big life-saving thing. I mean, this is an important piece of technology. Now, one of those things that we talk some about in this class is artificial intelligence replacing people, and I do want you to read to you these two paragraphs, because I think they're really critical to the concept. Among all of the applications of AI, I think digitally interpreting an image using an algorithm instead of a human radiologist is probably the furthest along. That's part of the reason I'm going to break from what they said there, or reading to you. But that's part of the reason why I've talked about, mammograms and radiologists, is because this is one of the ones that is the furthest along. Said Dr. Makar Pai, the director of McGill International TB Center in Montreal. Artificial intelligence cannot replace clinicians, Dr. Pai and other experts caution. But the combination of artificial intelligence, AI, and clinical expertise is proving to be powerful. As in, it's not that we're going to take and get rid of all the radiologists in the world. It's that we're going to give them better tools to work with. And those better tools are a life-saving thing. They're getting more of the diagnostic done right. They're getting it done at an economic price point so that it can be applied to people that aren't in the United States and wealthy. It combines the simplicity of something they already have and allows them to use it in a better way. And that's huge. So this article, I'd like you to read it. It's just a New York Times article. It talks a little bit about this. And talks a little bit about the impact of having a classification algorithm. And this is purely a convolutional neural network that's been trained on a bunch of things that is classification. It doesn't have any of the other fancy things that we're talking about. Some of these things for running a game or generating stuff are much more complicated to build. And basically, the piece of software that I gave you for discriminating between cats and dogs is the software that they're using for this. The only difference is the training set. and how much time they took to train it, which is a lot. But that software, minus maybe 5 lines of code that deals with some specific little details, and you could work out the 5 lines of code. That is the piece of software that is doing this. This is not some magic thing. And we're going to walk through a piece of software today that is more complicated than this, but I think, you have the basic skills in Python at this point to be able to say, yeah, I could walk through a piece of this software, I could analyze the software, and I may not know all the details, but if I do enough Google searches on the little pieces, I can figure out the details, and at a big picture level, you understand enough about this that you can actually take a look at it and say, yeah, this does basically what I want. The software isn't got some complicated recursive functions and processes and all this kind of stuff in it. The software is basically pretty simple, and it's the computer writing its own program through a vast amount of training data to be able to do this. So now it comes down to, what is the training data and how do I get the data in the right format? And I can't stress enough that you need to work with the data to be able to pull this off. Now, the other article also from the New York Times, and I'm going to spend a little bit more time on this particular article because we're going to have a homework. It's a really easy one for Thanksgiving coming out of this. It's not a programming exercise. It's go and do something. So this one was on the front page of the New York Times a couple days back, and it is pictures. This is not a person. This is generated by a computer. And I think looking at this picture, this looks a little bit odd right in here where I'm moving the cursor by her ear. I'm not certain what's going on right there. This article goes through a bunch of the things that you can look at in here to help you identify fakes. But the thing that I would say about identifying fakes is if they made a list of 7 things you can look at, I can train my neural network to overcome those specific 7, and it will not have those flaws anymore. So the article, again, is a worthwhile read. I do expect you to go and read these 2 articles in the New York Times because it gives you some weapons, at least at this moment in time, for identifying fakes. This person does not exist. And I think when I scrolled and it changed through a bunch of people right there, that gives you a clue that these are not, in fact, real people at all. The article does have some sliders in it where you can actually go and manipulate some of these images as you go through them. Okay? And you can go, oh, this can't be real because I can change this person on the fly and walk through different cases of what this person would look like. Now, these were created through a thing called a generative adversarial network, which is a pair of neural networks working against each other. This is not just 1, but 2. So you have to train 2 different things. The article goes through a little bit of this. This is the area with the sliders, and I particularly like this one on gender because I can do this, and I can turn a woman into a man and back and forth. That's not some comment on gender. That's because when you look at that, you can say, absolutely no way is that a picture of a human being. And it absolutely makes it clear. I mean, yeah, up here with mood, I could have had one person do the different moods and be able to program that in somehow, but you can't do the gender. And the same thing for race and ethnicity. If I turn it from a white person into a colored person on that slider, and I can manipulate it directly in real time on a slider and get the different pictures. Now, the way that they generated this, I'm not certain because they have to have used some sort of a thing that ties the slider to it. It's not generating those on the fly. They're not that fast to generate. But in both of those cases, it gives you a clue that this is not real. Now, I went out and actually found their software, and I want to walk through their software with you here in a second. And the link for this is in the notes for this week. And it gives you a nice example at the top about going through different cases of this and how you can change it. and where they got this, how they can change one thing into another and have the computer generate a variety of different things. So how does this work? Okay. Let's look at the diagram. And, it has some random noise that it takes and trains to generate in combination with some faces, generated faces. And then it uses a second neural network, that's the discriminator over here, to say, is this a good or is this a bad face? Is it a fake or is it a real? So you've got two different things you're training. You're training this generator over here, okay, and you're training this discriminator. So this makes it more complicated to train, and the question is, how good is the discriminator? And I think when you look at things like this, you can say, it's not perfect, but it's probably pretty darn good. And if you build a better discriminator, okay, you'd get a better result. So this is kind of the high-level picture, and it starts out with real faces. I think you've heard of Facebook, and you could probably scrape a few 100,000 faces off of it. And there is software these days that is really good at being able to pick out the faces. So the real faces combined in this fashion to train a generated set of faces and then a discriminator to classify it. And this nice article goes into the math, and when I look at something like that, I groan and I go, oh, I suppose I could understand it if I had to. But let's be serious. I don't necessarily have to understand it. The person that came up with this system had to understand it, but I probably don't. All I have to do is be able to program it unless I want to come up with a change to it that's fairly major. So they've already programmed this into a piece of software and figured out how to implement that. So, although I think it's important and, it's good to understand that when you get down to the code, and all the code is in here, you can actually run this. If you have enough compute power, I will tell you it takes a long time to train. And we're using some of these things, but we're not using all of them. And this is not using TensorFlow. It's using a different package for doing its neural networks. But you can look through this and you can go, yeah, NumPy is a package that manipulates matrices and stuff like that. Pandas is another numerical calculation and manipulation, and this thing that they're importing, Matplotlib, we're using that. You've walked through that, and you say, oh, I see they're doing images. They've got to calculate some heights and some widths. They're going to crop these. Same sort of thing we did with the dog and cat pictures. Is they went through and they did some sort of manipulation on the images. And then down here you see NumPy to do this calculation. And you go, oh, it's going to normalize the images. As in, it's going to take them in whatever brightness they are and convert them all to the same kind of color or same kind of grayscale so that it can train with them. And it's going to make the images all, again, NumPy, array of images. It's going to divide by 255. So it's got the images and it's going to take them and manipulate them in some fashion so that they all come out in a consistent size, shape, and brightness. And you've seen some stuff like this where we plot and then we show the plot. And guess what? Again, it's really important when you start playing with one of these data sets, take the time to add some stuff to get a look into your data set. Nothing is more frustrating than training for 2 weeks with a computer only to find out that, yes, you used the wrong data set. So literally, you can save yourself vast amounts of hassle by going, okay, yeah, this looks like the right data set. Okay. Then here's where they're going to create their generator for these things. And they've got these different processes that they're going through to build up the neural net instead of just saying, like we used an ReLU training process in TensorFlow. They've actually built the network instead of just saying, hey, this is the training process. And part of the reason for that is they're not doing a convolutional neural network. They're doing this different pair of neural nets. But again, down here is their function where they create a discriminator. So they've got two networks they have to train. When you go through walking through it, you go, okay, they're both ReLU networks, and they've got some things, and they've got some way they're dropping out data that's too small. They're doing this, they're doing that. I could poke through it. I could probably figure it out if I did enough searches. But basically, when they actually get to run it, they do create a generator, create a discriminator, and they sit here and they train this model on their pictures and their images. And once they get done, okay, they end up with a trained model that they want to run a number of iterations in the training. I will point out to you that this, by default, is running 20,000 iterations across thousands of images. If you go and run this on your laptop, you should probably take a break, a long break, because it's going to take a long time to run. It is not going to be a quick process. So this is one of those things where it would be really good to have dedicated hardware to do this. But again, you're training and you're working through this with a library. And when you get done, what does it do? It wants to take this and build a GIF image out of it. And that's what you're seeing when you're looking at the different images is, yeah, the output is a set of GIF images across a whole bunch of different images that it's trained. And down here, this should look reasonably familiar. This is on GitHub, which means that, yes, you can go out and pull up the source code for this. You can download it. And, there's the stuff. Okay? And here's where you can download it. They've got a little discussion. Here's where you can get the data from Kaggle. It's free. It's 1.3 gigabytes of images. So be prepared for it to take at least a little bit to download. And that refers back to the article that has the step-by-step going through this. So here's the key piece. Generative adversarial networks are dangerous. Yes, they are. This is like arming each one of you with something that you could turn into a nuclear weapon in a couple weeks worth of work. Because these have the ability of not just doing this, but this same piece of code, you want to train it to produce false voice. It can do that. You want to train it to produce a false video of somebody doing something? Yes. It can be trained to produce a video. A video is just a series of still pictures, and you want to train it? Yes, you can train it to do that. And people have done this. Now, your homework exercise is to go to This Person Does Not Exist. That's this website. And the link is in the notes. I will put it in the homework as well. And go through and just refresh it a few times. Okay? You can do that with either the refresh on the browser, or you can go, there's a little button when it gets done that says another. And we've produced 2 child images. There's an adult. And go through and use some of the things that you've seen from the New York Times article and find a goofy image in here. And it shouldn't take you long to find one. Here's one right here. They mention earrings. Earring on one side, not on the other. Glasses, the arms are different. Okay, so here's an example of an image that probably is not a real person. Now, you get something like this with a person and another person in it. They suggest things that have a fuzzy background are probably not real images. It is one of those things that is simple to implement using pandas, is a separator to cut out the background and replace it. And it would not take very much to take one of these images, apply the background detector, cut out the background, and replace it with a real background. And suddenly that would be fixed in the image. And could that be detected with a piece of software? Yeah, but as a human being, would you detect it? Probably not. Here's a good example of a goofy image. The picture of the person is pretty good, but what is this thing off here on the right-hand side? That's a good question. It doesn't look like anything normal. It looks like something weird. And each one of these cases, what is going on in the background here? It is very bizarre. And it kind of looks to me like an aerial photo of some land or her shirt, but it's in a weird position. So some of these things don't work out well, but I will also point out to you that a lot of these things are going to get fixed. A better training model that takes and rejects things that have any of these flaws, and something that detects these specific set of flaws will get rid of these. And suddenly you'll see images that are that much better. Now, if I worked in Hollywood and I was an actor or actress, I would be looking at this stuff going, they are going to automate acting out of existence before very long. And it's these days a pure digital medium. And why do they need actors and actresses? Because they're real and they're expensive and they sleep at night. And sometimes they get the cold and they can't work and it's expensive that day because you don't actually shoot. So, it's only a matter of time before some things like that are just basically non-existent. Will all of them be gone? No, there'll still be live performances. And, off-Broadway will still be off-Broadway with real actors and real actresses. But movie production, I bet you, will replace an awful lot of this stuff with complete digitals. Even complete digital composites of people that actually exist that they hire. But again, it will allow them to do all sorts of things that they can't do right now. So your homework is to go out to this person is non-existent, run it a bunch of times, and take a look at some of these things. And see if you can find one like this, where mismatching earrings and the ears actually don't match. This person has two different ears. So it's worth going and taking a look at it. If you want, I have done this. I have downloaded the code and actually gotten this code to work and played with it. He says he trained for 15,000 epochs. When I trained this on my laptop, the one that I'm recording this on, which is a pretty darn fast laptop, each epoch takes about 30 seconds to train. Do the math, you're probably going to want more hardware if you're going to train it for that number of epochs. But the availability of that hardware is greatly increasing. And I do not yet have access to one of Apple's new M1 chips that has a dedicated neural network piece of hardware in it. But I bet you that will run 1,000 times faster than doing this training on a CPU. And certainly, here at the university, we also have resources for specifically high-performance training of these sorts of things. So these kind of machines are becoming increasingly common, and they're going to have an impact on lots of things that we do. I haven't tried training a generative adversarial network like this to do some sort of a classification project, but I think it can be done. So this kind of gives you an overview of this kind of a thing. And I wanted to cover this. This is a short week. Thanksgiving is coming up. I wanted to cover this and give you an easy homework for Thanksgiving. And also to help you start to identify that just because you see a picture, just because it's written, think about GPT-3, doesn't mean that there's a person behind it. It doesn't mean that it's even real. It could be complete fiction. And just because there's some person out there that, has a blog and has a picture and has a bunch of images on it, that doesn't make it actually a human opinion. It could just be a set of parameters that's programmed in to generate content. And all of these things together, mean that your level of being able to look at this stuff is going to require, to get any sense of truth, you're going to have to rely more and more on Is it something like the New York Times that actually has an editorial staff and actually looks at what is true or not? Is it something like the Washington Post? And you may not like the biases of it, but at least you know when you read an article in one of those things that yes, there is actually an editorial process going on. They actually had human beings go out and hopefully check that what they're saying is at least accurate. You may not think it's true, but it's at least accurate. Okay? Because if they get it wrong at some institution like that, they can get sued. Okay? So they have an incentive to make certain that what they publish is at least not libel or slander, and is at least accurate, and isn't... It may have a political bias, but it doesn't have a complete falsehood to it. And when you just go out and read some random thing from some site on the news, or you read something that puts up random information all the time, like RT, Russia Times, which used to be called Pravda during the Soviet era, okay, you can be guaranteed that that has no incentive to get things right. It only has the incentive to present a biased point of view of the people that manipulate it and use it. So you got to look at these things in the modern context and look at what that means in our world. And this is the power, and this is what you have at your fingertips, is the ability to not just look at it, but to generate it for yourself. And with that, I hope you have a wonderful Thanksgiving, and stay safe, stay healthy, safe travels, and we will catch you later.